In this section, I will introduce an important class of the function called exponential functions. These functions are used extensively in modeling and solving a wide variety of the real-world problems, including growth of money at compound interest, growth of populations, radioactive decay, and learning associated with the mastery of such devices as a new computer or an assembly process in manufacturing plant, etc. Of course, for your field, we will talk about the compound interest in this section with the exponential function. Let's start by the notation. The exponential function is denoted by the following way. For example, to the power x. Okay, this is exponential function. This is exponential function. But sometimes you think that these are the same or similar functions, g of x, which is x squared, okay? So these are completely different, okay? Not the same functions. Actually, in the first function, 2 is the base. Base is constant and the power is a variable, input value or independent variable. Here, the base x is independent variable and the power is constant, okay? Whether a variable appears as an exponent with a constant base or as a base with a constant exponent make a big differences. The function g is a quadratic function or second degree polynomial. We have already discussed. The function f is a new type of the function called an exponential function. In general, we can give the definition of the exponential function. The equation or the function, actually your textbook says equation, we can say the function b to power x here b bigger than 0 and different than 0. So different than 1. Defines an exponential function. For each real number b, okay, for each different constant b is constant. Here b is called the base, and the domain of the exponential function is the set of all real numbers, and the range of the function f is the set of all positive real numbers. Actually, why we need the positive b? We require the base b to positive to avoid imaginary numbers, such as, let's write here, if b is minus 2 power x minus 2 power 1 over 2, for example, is square root of the minus 2. So this is complex number, imaginary number. Maybe you know, maybe you don't know, I'm not sure, but I times square root of 2. Here, I denotes square root of the minus 1. So we exclude b equals 1 here. As a base, since if b equals 1, f of x will be a constant function. So in that case, if b equals 1, f of x equals 1 to power x, so which is always 1. So this constant function have already considered in the lectures. When we need the graph of the exponential function, for example, to the power x or to the power minus x, okay, many students don't hesitate. Maybe here I can say something. Y equals to the power x, another function to the power minus x, but this function is not in the form of the definition because this is minus x, but actually this is exponential function since which equals to the power minus 1 to power x, so which is 1 over 2 to the power x, so b is 1 over 2. Okay, so this is also exponential function. So if we sketch the graph of this function by using the plot point-to-point sketching idea, we can find the following graph. For example, for the function to the power x, if x is 0, to the power 0 is 1. So it is passes through the point 1 when x equals 0. When x equals 1, it is 2, for example. When x equals 1, that is value is 2. This point. If it is 2, its value is 4, somewhere here, etc. If x is 1 or minus 1, this is 1 over 2. If x is minus 1, the value is 1 over 2. If x is minus 2, the value is 1 over 4. Okay, so the graph by using point sketching idea like this one. So this is y equals to the power x graph. If your function is y equals to the power minus x, for x equals 0, again this is 1. For x equals 1, this is 1 over 2. For x equals 1, the value is 1 over 2. For x equals 2, the value is 1 over 4. So for x equals minus 1, to the power minus times minus 1 is 2. So that value is 2. For x equals minus 2, if you want, you can sketch at which is value 4. So the graph like this one. Here, x-axis, in other words, y equals 0 line, is horizontal asymptote of the both function. Okay, so y equals 0 line is a horizontal asymptote for exponential function. Let's talk about some basic properties of the graph of the exponential function. as a theorem. Basic properties of the graph of f of x equals b to power x. Of course, here b bigger than 0 and different than 1. Together we can write different than 1 and bigger than 0. So the first property is all graph will pass through to point 0, 1, because when x equals 0, f of x is 1. Okay? All graph will pass through the point 0, 1. So y-intercept is 1. Second property is all graphs are continuous curve. You don't know what is continuous. After learning limit concept, you will learn. But the meaning of continuous, I explain. Without raising your hand, you can sketch the graph. Okay. So all graphs are continuous. That means there is no hole, there is no jump, etc. Third property is the x-axis is a horizontal asymptote. The x-axis, in other words, y equals 0 line, is a horizontal asymptote. And third property is if b bigger than 1, then b to power x increase as x increase. So the graph like the function to the power x. This graph is the y equals b to power x graph. And the fifth property is if b is between 0 and 1, then b to power x decrease as x increase. So the graph like to the power to the power minus x graph, yes, or 1 over to the x graph. So the graph likes this one. So y equals b to power x graph like this one. From the graphs, I can make some remark. I can say something. Recall that the graph of rational function has at most one horizontal asymptote, and that is approach the horizontal asymptote, if exists, of course, both when x goes to infinity and when x goes to minus infinity. The graph on exponential function, on the other hand, approaches its horizontal asymptote as x goes to infinity. When x goes to infinity is approached to y equals 0, or x goes to minus infinity. So here when x going to minus infinity, it approached to 0 value. But not both. In particularly, there is no rational function that has the same graph as an exponential function. So these are completely different functions. Okay, now let's talk about the properties of the exponential function. Properties of exponential function. For a and b positive, these will be base of the exponential function. So a should be different than 1 and b have to be different than 1, and x and y real numbers. don't consider the y as a function of the x. Okay, here both of them as a unknown. Both of them are independent variable. Okay, because you will get some properties of the exponential function. Maybe, most probably you know from the high school. So first is exponent laws. Okay, this can be considered as a recall. E to power x times e to power y. If the bases are the same, the product of the two exponential term equals summation of that one. I mean a to power x plus y. So you take the summation of the power. So let's give example. For example, 4 to power x times 2 to power 2y, or let's say 4y. So you should make the bases the same. So 4 is 2 square. So this is to the power 2x. So 2 square to power x. Actually here we have another rule. Here we have another rule. Maybe I can write. Okay, let's write here as another rule, as a recall. So e to power b to power c equals e to power b times c. Okay, so that will be to the power 2x times to the power 4y times to the power 4y. So to the power 2x times to the power 4y. As a result, this equals to the power 2x plus 4y as a summation you can write. And from here you can obtain another result. E to power x over e to power y equals e to power x, that 1 over e to power y is e to power minus y. So it's e to power x minus y. Okay, you can obtain this result. This recall, maybe we can write this recall also here. Okay, let's repeat. E to power x to power y equals e to power x times y. And also we have another rule, e times b to power x equals e to power x times b to power x. I think that you know these all rules from the high school. And second rule, or law, you can say, it does not matter. If e to power x equals e to power y, since function is continuous and one-to-one, there is a unique solution. So if and only if x and y equals, so if and only if means if e to power x equals e to power y, this equation implies x and y equal. If x and y equal, this implies e to power x equals e to power y. Maybe this side is very clear for you. And the third property is for the x which is different than 0, e to power x equals b to power x if and only if a and b are the same. A equals